Welcome, Discrete Math students. In this video, we will learn how to make an adjacency matrix from a vertex edge graph. Rectangular arrays of numbers, like the one below, are sometimes called matrices. Matrices can be used to represent graphs. One way in which a graph can represented by a matrix is shown in the partially completed matrix below. This matrix shows the number of times that each vertex is connected to another vertex. You'll notice our rows and columns are both labeled for all of the points. Let's look at what some of the individual values represent. Notice there is a 1 in the A row B column. This means that there is one edge connecting points A and B. There is a 0 in row A, column C, because there are no lines that connect A and C. Let's fill in row B together. The first thing we are looking for is how many lines connect B to A. We already found above that B and A are connected with one line. Our next spot is looking for B to B. There are no lines connecting B to itself, so that becomes a 0. B and C are connected by one line. There's a 1. B and D are not connected at all. 0. B and E are not connected. 0. And B and F are not connected. That's also a 0. Notice that this adjacency matrix is made primarily of zeros and ones. It is possible to have other numbers. Notice that D and C have a 2. That's because D and C are connected by two lines. Vertices in a graph that are connected by an edge are said to be adjacent vertices. The matrix we began is called an adjacency matrix for the graph, since it contains information about vertices that are adjacent. Each entry in an adjacency matrix is the number of direct connection, or edges, between the corresponding pairs of vertices. Let's make an adjacency matrix for one more graph. Let's make an adjacency matrix for this graph. To make an adjacency matrix, we begin by labeling our rows and our columns with the letters of the points. I have labeled my points L, M, N, and P, both across the top and down the side. Now we start by filling in each connection. Our first spot is L and L. That is a 0, as there are no connections between point L and itself. Then I look at L and M. L and M are connected by one line. L and N are also connected by one edge. And finally, L to P are connected by two lines. One thing to notice is that I can look at point L and find it has a degree of 4. Looking at the sum of row L, 0 plus 1 plus 1 plus 2 also equals 4. Our second row, M to L, we already found that is connected by one edge. M to M is 0. M to N, there's two edges connecting that. M to P is 0. For row N, N to M are connected by two edges. Whoops, that was M to L, excuse me. N to L is connected by 1. N to M is 2. N to N, 0. N to P, 1. And finally, our last row, P and L have two connections. P to M, 0. P to N, 1, P to P, 0. One additional quick thing to notice that can help you check your work is notice that if you did it correctly, your column and rows of the same names should match. So my P column, 2, 0, 1, 0. My P row, 2, 0, 1, 0. And this is the adjacency matrix for this vertex edge graph.